Assalamualaikum and hi everyone, welcome back to my channel. Siapa yang belum subscribe channel Madam Fika Fiki, boleh tunjukkan support anda dengan menekan butang subscribe. Jadi hari ini kita nak discuss satu set soalan sebagai persediaan bagi menghadapi final exam yang akan tiba tidak lama lagi. Jom kita mula. Alright, let's discuss the first question. Show that the equation S equal to UT plus half AT squared is dimensionally correct. Alright, so question number 1. So we have S is equal to UT plus half AT squared. Alright, so in order to check the equation is dimensionally correct or not, okay, we need to compare the both sides. Alright, so the both sides must have the same dimension. Okay, so make sure you know that the both sides must have, okay, the same dimension. Okay, so that's mean the equation is dimensionally correct. Okay, so now let's start. So we have left hand side and right hand side. So I'm going to highlight the left hand side with the yellow color, and the green color is for the right hand side. Okay, so let's start for the left hand side. Okay, so we want to find the dimension of S. So as we know, the dimension of S is equal to L. Okay, so for the right hand side, we have UT. We want to find the dimension of UT plus half. So this is constant. So AT squared. Alright, so as we know, the dimension of U is LT negative 1 and T is T. I'm going to write here LT negative 1 T plus, so now we have A and T squared. The dimension for the acceleration is LT negative 2 and T squared is T squared. Okay, so when we simplify, you can see here, we can cancel the T here and this T. Alright, so dimension for the right hand side is equal to L plus L. Okay, remember that you cannot add the dimensions together. L plus L cannot be 2L. Alright, it's wrong. Okay, it's not equal to 2L. So L plus L, so dimension is L. Okay, so you can see here the left hand side and the right hand side are equal. So we can write as left hand side, okay, left hand side is equal to right hand side. Okay, since we have L is equal to L. Therefore, okay, both sides have same dimension. Okay, and means that the equation is homogeneous. And the equation is dimensionally correct. Okay. Okay, question number 2. Figure 1 shows the motion of an object in a straight line. So if you look at to the figure 1 here, so we have a graph of V against T graph. So remember, when we have a graph of V against T graph, the gradient of the graph, okay, will give you the value of the acceleration of the motion. Okay, question number 1. Determine the acceleration of the object for section PQ, QR, and RS. So now we have PQ, and I'm going to use this one, QR, and this is RS. Okay, so now let's try to calculate PQ first. As we want to find the acceleration of PQ, so we need to find the gradient, okay, of the graph, the line PQ line. So we need to find the gradient of PQ line. Alright, so it's equal to 20 minus 0, y2 minus y1 over x2 minus x1. Okay, so it's equal to 5 meter per second squared. Okay, and how about QR? Okay, it's the horizontal straight line, so no gradient. So straightly it's equal to 0 meter per second. And the last one is acceleration for RS. Okay, so you can see here RS. So now this is the y1 and this is the y2, 0. And this is the x2 and this is the x1. Okay, you must know which point is for initial and which point is for the final. Okay, so now QRS, so we have 0 minus 20, not 20 minus 0. Okay, be careful. And the x component we have 10 minus 8 second. Okay, so the answer is equal to negative 10 meter per second squared. Okay, so now why it's negative, you can see here. Okay, the velocity from R to S is decreasing from 20 meter per second to 0, means that the motion of the object is decelerating. That's why this is negative 10 meter per second squared. Alright, and for the second one, okay, so now we want to find the total distance traveled after 10 seconds. Okay, so in order to calculate the total distance, okay, total distance travel, so we can calculate the area under the VT graph. Area under VT graph. Okay, so now you can see here, this is the area under the VT graph. It's a trapezium shape, so we can calculate the trapezium. It's the area is trapezium, so it should be half times 10. So this is 10 here. Okay, 10 plus 4 and the height is 20 times 20. Okay, so it's equal to 140 meter. So this is the answer. Alright, and the last one, we want to sketch the acceleration time graph for the whole journey. Label the values of the acceleration at 4 seconds, 8 seconds, and the last one is 10 seconds. Okay, so the third one, okay, we want to sketch the graph of, okay, y-axis and x-axis. Okay, so we have A, the unit, make sure you write the unit, and T is the time in seconds. Okay, so 0, so we're going to have 4, 8, and here is 10. Okay, make sure you label the time first. Okay, so we have calculated the acceleration just now. APQ is 5, AQR is 0, and ARS is negative 10 meter per second. So now let's label all the values. So we have here 5, and let's say here is 10. So I'm going to make this line It's longer. Okay. So now here is negative 10. Okay. So now for PQ, we have 5 meter per second. So in 4 seconds, okay, in 4 seconds, the acceleration from P to Q is 5 meter per second squared. Okay, so I'm going to draw a straight line. Okay, that one. And from 4 to 8 seconds, Q to R, it's 0. Okay, so we have here. And the last one is 10. Okay, from 8 to 10 seconds, it's negative 10. Okay, so now you can see here, from 0 to 4 seconds, the acceleration from P to Q is 5 meter per second squared. Okay, and from 4 to 8 seconds, so we have 0 meter per second squared. And from 8 to 10 seconds, so we have negative 10 meter per second squared. Alright, so we have finished question number 2. Okay, question number 3, we have a 8 kg body moves towards the west with a momentum of 30 kg meter per second. So let's say we have, this is a mass of a body which is 8 kg. It moved to the west. Okay, and given that the motion is in this direction, so the value must be negative value. Okay, because we take the direction is to the left is negative. So the momentum, so it's given that the initial momentum is 30 kilogram meter per second. So that's mean it's negative 30 kg meter per second. Why negative? Why I put negative? Because as we know, P, initial P is equal to mu. So since u is negative, so P here is also negative. Okay? Alright. So now when it's moving to the west direction, so what happened next? A 20 Newton force to the east acts on the body for a period of 15 seconds. So let's imagine that the 20 Newton force, okay, so let's imagine that this is you and you are trying to stop the body from moving. Then you put 20 Newton force on the body. Alright, so the force, so it must be in this direction. So the force is 20 Newton and it's 15 seconds. Alright, determine the magnitude of the impulse of the force. So when we put a force on the body, so we can calculate what is the impulse of the force. Okay, so let's start. So question number 1, we want to find the impulse of the force. So we use J is equal to Ft, where F is the force, is 20 Newton, and time is 15 seconds. And the answer is 300 Newton second. Okay. And second, we want to calculate the change in the momentum of a body. So remember that impulse can write as, you get here, so impulse we can write as J is equal to Ft, and impulse also is equal to the change of momentum. So that's why we also can write J is equal to delta P. So as we want to find the change of momentum of a body, so it's equal to 300 Newton second. Okay? And the third one, we want to find the final momentum of the body. So remember, the change of momentum is equal to momentum final minus momentum initial. So now we want to find the final momentum. So it's P final is equal to delta P plus P initial. So as we have the value of delta P is equal to 300 plus initial momentum is, remember the direction, negative 30. Okay? And P final is equal to 270 kg meter per second. Okay, so we finish question number 3, and the last one is the part 4. We want to calculate the final velocity of the body. So we can calculate the final velocity because we have the value of the final momentum is equal to mv, where v is the final velocity. So now we can find v is equal to pf over m. So it's equal to 270 over 8, and the final velocity is equal to 33.75 meter per second. Okay, so finish question number 3. Okay, question number 4. A 25 kg crate is pushed at constant speed. So when we talk about constant speed, means that the acceleration is equal to 0. Okay, excellent. Okay, so now the object is across a rough horizontal floor. So means that when we put a force at angle of 20 degree, we try to push the object. What happened? It will move in this direction. Okay, the direction of the motion should be to the right. Ikut logiknya lah. Okay, so the direction of motion should be in this direction. And the frictional force. So since the surface is the rough surface, so there is a frictional force which is opposite direction with the motion. Okay, alright. So now let's try to sketch other forces that involve in this case. So we're gonna have, as usual, the weight of the object, and since the object has the contact with the surface, so there is a normal force. So the direction of the normal force should be upward. Okay, good. Alright, so now if we want to transfer all the forces in one free body diagram, so let's try to sketch the free body diagram. So question number 1, sketch a free body diagram of the crate. So we put a dot to represent a body. Alright, so we're gonna have x component and this is y component. Okay, x component and y component. Alright, so now look at our diagram. So we have normal, weight, frictional force and external force or applied force at angle of 20 degree below the horizontal. Okay, so we need to transfer this arrow so that the tail of the arrow must be at this point. Okay, the tail of the arrow must on the dot. Okay, tak boleh kepala dia dekat dot. Must be the tail of the arrow on the dot. Alright, so let's try to sketch. So we have normal, and then we have weight downward, we have frictional force, and you can see here, okay, so the arrow should be in this direction. Okay, saya lukis dulu. Okay, so it should be like this one, F. But remember, for the free body diagram, all the tails of the arrows must be on the dot, tail dia. Okay, so kita transfer. So if this is 20 degree here, so when we try to transfer to here, so we have F here, and if this is 20 degree, this is also 20 degree. Okay, so saya padam. Alright, so now you can see here, all the forces, okay, are in the correct place and the correct direction. Okay, so siap. So this is our answer for number 1. And second, determine the normal reaction on the crate. So we want to calculate what is the value of n. Okay, so you look at here. So n is on y-axis, so we can write as total Fy is equal to 0. The object is not moving in y direction, so it's moving in x direction. So A here. Okay, so now total Fx is equal to ma. But remember, since the motion is constant speed, so acceleration is equal to 0. So total Fx also equal to 0. So now, before we start our calculation, remember, if there is a force at an angle of theta, we need to resolve into x and y component. Okay? So now, I want to resolve F into x component. Fx equal to F cos 20, while we have another one is Fy. Okay? So this is Fy, where Fy is equal to, tak muat pula kat sini kan? So Fy is equal to negative F sin 20 degree. Okay, so now, look at the total Fy. So, on y component, we have N, Fy, and W. We have N, Fy, and W. Okay, so now, let's write the equation. N plus Fy, so the total force in y component, N plus Fy plus W is equal to 0. Okay, but remember, okay, we do have the direction. Okay, because the direction of Fy and W is downward. So N plus negative F sin 20 degree plus negative mg is equal to 0. So now, N is equal to F sin 20 plus mg. Okay, so look at the equation. Okay, we have value of m, g, but how about the force? So we do have F, where F is equal to 20 Newton. So we can straightly calculate our normal force, okay, where it's equal to 20 sin 20, okay, plus mass is 25 times 9.81, and the answer is equal to 252.1, okay, or 252.09 Newton. Okay, so this is the answer. Alright, so let's proceed to question number 5. Okay, question number 5, you want to find the force that acts on an object as a function of x is shown in figure 3. Okay, we have a graph F against x. Calculate the work done. So calculate the work done by the force in the interval x bigger than 0 and smaller than 4. Okay, so as you know, when we have a graph F against x, so we can calculate the work done by the force by calculating the area. Okay, the area under the Fx graph. Okay, so now so since the graph is trapezium shaped, so the area should be half. So you can look at the base is 4 plus 2, okay, times the height is 5. Therefore, the area is equal to 15 joule. Okay, so work is equal to 15 joule. Okay. Okay, so question 5b, we have 25 gram bullet moving with speed 200 meter per second. So now we have a bullet here. Okay. Where the mass of the bullet is 25 gram. So I will write 0.025 kg. And the initial speed of the bullet is 200 meter per second. Okay, so what happened? The bullet hits a wooden blocks and stops after penetrating 35 centimeter into the block. For example, let's say we have a block here. Okay, so let's say this is the bullet. Okay, alright, where it's 35 centimeter. Where from here to here is 35 centimeter, which is 0.35 meter. Okay, and the final velocity of the bullet should be 0 because it stopped. Okay. Okay, so using the work energy theorem, calculate the average frictional force experienced by the bullet. So, as we know, the bullet will stop after entering the block. What happened? So, it is because there is a frictional force that against the motion of the bullet. So, the bullet will do some work in order to against the frictional force. Alright, so based on the work energy theorem, we can write W is equal to delta K, where there is a change in the kinetic energy of the bullet. Initially, the bullet is moving with 200 meter per second speed, and finally, the speed becomes 0 because it stopped. Why? Because the bullet do some work to against the frictional force. Means that the work done by the bullet to against the frictional force. Okay, so when we calculate the work done by the bullet to against the frictional force, it's equal to final kinetic energy minus initial kinetic energy. Okay, so we can write as half m V final squared minus V initial squared. Okay, so we can substitute the value. So you can see here that the final velocity is 0, while the initial is 200. So the answer here will be negative 500 joule. Why it's negative? So the negative sign showing us that the bullet doing some work or work done, okay, work done by the bullet to against the frictional force. Okay, alright. So now, as we want to find the average frictional force, so another equation to calculate the work done. Okay, it's equal to W is equal to frictional force times S. Okay, and it's equal to, so W here is negative 500 joule, F and S is 0.35. Means that the bullet doing 500 joule work in order to move 0.35 meter inside the block. Okay, so the frictional force is equal to negative 500 over 0.35. Okay, so the answer is negative 1429 Newton. And the average frictional force experienced by the bullet, or the amount of frictional force that experienced by the bullet, is equal to 1429 Newton. Okay, and the direction is always opposite direction of the motion. Okay, so means that, okay, the bullet is moving in this direction, right? Okay, so the direction of frictional force should be opposite direction. Okay, so that's all. Okay, so now question 5C. A 50 kg box is lifted through a vertical distance of 20 meter in 3 seconds. Okay, means that, let's say this is a floor. So we have a mass here, which is 20 kg. What happened? Okay, so the object is moving upward or lifted upward, and the distance is, the height is 20 meter in 3 seconds. Okay, so there is a change of height. Okay, so we also can find the value of work done on the object is equal to the change of the potential energy. So it's equal to U final minus U initial. But the question asks us to find the power employed. Okay, so as we know, the equation of power is equal to W over T. Therefore, since there is a change of height of the box, so we can find U, the change of potential energy, over T, where it's equal to mgh final minus mgh initial over time. So initially, there is no height, so this is 0, and power is equal to 59.81, height is 20 over 2 is equal to 3270 watt. Okay, so finish questions 5C. Okay, question number 6. We have a conical pendulum with a bob of mass 0.5 kg. Okay, so mass is 0.5 kg. And the length of the string is given 0.75 meter. So the length is 0.75 meter. Okay, and swings in a horizontal circle of radius 0.3 meter. Okay, and the radius of the horizontal circle is 0.3 meter. Find the tension in the string. Okay, so before we start, we need to draw the free body diagram first. Okay, so let's start. So we have wick as usual, the wick of the bob. Okay, and then the tension. So the tension must, okay, and then the tension must be directed outward from the object. Okay, and that's all. We just have tension and wick. Okay, so since the object is moving in horizontal circle, so means that the direction of the centripetal acceleration towards to the center. So the center. So AC. Okay, so now let's resolve first. But we need to find the angle theta. Okay, so so this is the triangle. So we have 0.75 meter and 0.3 meter, and find the angle theta, where theta is equal to, so I'm going to use cos, okay, inverse tangent cos 0.3 over 0.75, so it's equal to 66.42 degree. Okay, so now let's resolve. So we have wick here, okay, and then T here, where the angle is 66.42 degree. Okay, and then we can resolve T into Ty and Tx. Okay, where Ty is T sine 66.42 and Tx is equal to T cos 66.42. Okay, so before that, the direction of the centripetal acceleration is in this direction, AC. Therefore, the equation should be total Fx is equal to MAC, where in x component, we just have Tx. Okay, we only have Tx. Okay, so Tx. So Tx is equal to T cos 66.42 equal to MAC. We want to solve for the value of T. What is the tension in the string? But we don't have the centripetal acceleration. Okay, here. Okay, we don't have centripetal acceleration. Okay, and T. So we cannot use this equation. So let's move to the y component, where total Fy is equal to, must be equal to 0. Why? Because the object is moving in horizontal circle, not moving in y components or in y direction. So it's equal to Ty plus negative W equal to 0, where Ty is equal to T sine 66.42, equal to mg. Therefore, T is equal to mg over sine 66.42. Substitute all the values, where the mass is equal to 0.5 kg, gravitational acceleration, and sine 66.42. Make sure your calculator is in degree mode. Then tension is equal to 5.35 Newton. That's all. Question 7, we want to calculate the minimum speed which the body must have to escape from moon's gravitational field. So given that the moon has a mass of 7.7 exponent 22 kg and the radius of the moon is 1.7 exponent 6 meter. So let's write the mass of the moon. And the radius of the moon is 1.7 exponent 6 meter. So if we have a body and the body want to escape from moon's gravitational field, so we need to calculate what is the velocity, or what is the minimum escape velocity. So the equation is square root 2gm over r. So this is the capital M showing for the point mass. So it's equal to square root 2 6.67 exponent negative 11 and 7.7 exponent 22. So over 1.7 exponent 6. Therefore, escape velocity is equal to 2458.1 meter per second. So this is for question 7a. So for question B, we have two satellites are in circular orbits around the Earth. So satellite A is at an altitude. So altitude means that satellite A is at position above the surface of the Earth, where the altitude of the satellite A is equal to the Earth radius. So let's say this is the radius of the Earth, r, and this is the position of the satellite A. So I put as MA. So satellite A orbiting the Earth at this position. Something like that. And for the second satellite, which is satellite B, and the position of the satellite B is at an altitude equal to twice the Earth radius. Let's use another color. So let's say this is B. MB. Oops. Something like that. Where the distance from the surface of the Earth to satellite B is 2r, and the distance from the surface of the Earth to satellite A is r. Ini sepatutnya bulat ni, tapi tak bulat sangat kan. Tak apa. So calculate the ratio of their periods TB over TA. Alright, so as we know, the equation of the period of satellite to move in one complete revolution is equal to T 2 pi square root r cube over gm. So we want to find TB over TA. Therefore, I would write as TB over TA. Okay, and it's equal to 2 pi square root R, here is B. So RB cube over GM over 2 pi RA cube over GM. Okay, so this one we can cancel 2 pi and we can take squared for the both side in order to cancel the square root. Okay, so we can cancel and we can cancel this one as well. G is constant, so we can cancel all the constant values. Okay, so now we have TB over TA, and this is squared, and it's equal to, okay, RB cube over RA cube. Okay, so now we want to cancel the squared. Okay, so we take the square root again. So we have square root RB cube over RA cube. Okay, so now we can take the square root where RB is, from the center of the earth, is R plus 2R. It's equal to 3R, and RA is R plus R, so it's equal to 2R. Therefore, we substitute the value here, 3R cube over 2R cube. Okay, so actually we can cancel the R. Okay, you can cancel this one and cancel this one. And it's equal to square root 3 cube over 2 cube. And the answer is equal to 1.837. Okay, so no unit because it's a ratio. Okay, it's a ratio of their periods, TB over TA. Okay, so let's proceed to question number 8. Okay, question number 8. We have a figure 5. Shows one pistons of an internal combustion engine. So as the crankshaft rotates through 360 degrees, the top of the piston moves from L to T and back to L. Means that for one complete revolution 360 degrees, so the pistons move from L to T and goes to L. So for one cycle, it's from L to T and back to L. Alright, means that if we have L to T and move to L, so let's say this is the starting point, which is 0 degree, and this is 180 degree, and this is 360 degree. Okay, so it's given the distance of LT is 9.6 centimeter. Okay, so we have L to T is 9.6 centimeter. Okay, so means that from 0 to 180 degree, so it's 100. So means that from 0 to 180 degree, so it's 9.6 centimeter, and this is another 9.6 centimeter. Okay, so for one complete revolution, so we do have this type, okay, of graph. Okay, so as we know, okay, so this is pi over 2, which is 90 degree. Okay, and this is 180 degree, and this is 270, and this is 360. Okay, alright, so now it's given that the crankshaft rotates at 3600 revolution per minute, so we can calculate the omega, 3600 revolution per minute. So we need to change it into radian per second. Okay, so revolution, so one revolution is 2 pi radian. Okay, and 1 minute is 60 seconds. Okay, so after calculation, so we have omega is equal to 376.99 radian per second, or 377 radian per second. Okay, so the question state that determine the frequency of the oscillations. Okay, so we want to find what is the frequency. So for A, we have omega is equal to 2 pi f. So f is equal to omega over 2 pi, where omega is 376.99 over 2 pi, and the answer is 60 hertz. Okay, and so B, the amplitude of this oscillation. Okay, so look at here. Okay, so look at here. From 0 to 180 degrees, so this is for the half cycle, from 0 to 180 degrees. So the distance traveled by the pistons is 9.6 centimeter. Okay, 9.6 centimeter is the distance traveled by the pistons. Okay, so now if we want to find what is the amplitude here at 90 degree, okay, so we want to find here at 90 degree, what is the amplitude here? Okay, so the amplitude here we can calculate by using this information. Okay, if from 0 to 180 degree is 9.6 centimeter, so from 0 to 90 degree, from 0 to 90 degree, it should be half. So the amplitude we can calculate by using 9.6 divided 2. So the amplitude is equal to 4.8 centimeter. Okay. Okay, C, calculate the maximum kinetic energy of the piston given the mass of the pistons is 700 gram. So 700 gram is equal to berapa tu? 700 gram is equal to 0.7 kg. Okay, so for kinetic energy, so kinetic energy will be maximum when at x is equal to 0. Okay, 0 meter. Okay, so now by using the equation, we can calculate K maximum, kinetic energy maximum, is equal to half m omega squared a squared minus x squared, where when x is equal to 0, kinetic energy is maximum. Okay, so we can substitute half, so mass is 0.7 and omega is 376.99 squared, and the amplitude is 0.048 meter squared. So make sure you press your calculator carefully. So the maximum kinetic energy is equal to 114.61 joule. Okay? Alright. Okay, so for D, at which positions in movement of the piston will this acceleration be 0? Okay? So we want to find at which position, okay, in movement of the piston, this acceleration will equal to 0. So according to the simple harmonic motion, so we can write according to simple harmonic motion, in order to find acceleration, A is equal to negative omega squared x. Okay, so the acceleration will become 0, okay, when x is equal to 0, then the acceleration is equal to 0. Okay? Okay, so when we have a graph like this before, okay, so you can see here, so at this point, let's say this is halfway, okay, 180 degree kan, so this is 360 degree, so the piston start from L to T and back to L. Okay, from L to T and back to L. Okay, so this is the amplitude A, alright, and this is 0. So we can see that, okay, x is equal to 0. Okay, so this value will equal to 0 when the revolution is at 180 degree. Okay, 180 degree means that the movement of the pistons is at the midway of the movement. Okay, so therefore we can say that the acceleration will be 0, okay, at the midway of the movement of the piston, which at T. Okay, you see here, so this is T. So the piston start from L, move to T and back to L. Okay, so if from 0 degree, you can see here, if from 0 degree to 90 degree, okay, here at 90 degree, x is equal to A, the amplitude. At 180 degree, which is the halfway of the motion or the midway of the movement of the pistons, okay, at 180 degree, this point x is equal to 0. So according to the simple harmonic motion, when x is equal to 0, when this value is equal to 0, A is equal to 0. Okay, so mungkin ada awak keliru, kadang-kadang ada buku guna X dan ada buku guna Y. Okay, so doesn't matter lah, sama saja. Okay, Y pun kita boleh pakailah. Okay, you boleh letak sini X ataupun sini Y. Okay, so yang penting you faham nak substitutekan value tersebut. Okay, alright, so let's move to question number 9. Okay, question number 9a, we have a standing wave equation here, which is y equal to 8.0 cos 0.5 pi x sine 40 pi t. Okay, so let's compare with the general equation, which y is equal to a cos kx sine omega t. Okay, so from here we can compare that this is the value of a, and this is the value of 0.5 pi is the value for k, and 40 pi is the value for omega. Okay, so the unit for x and y in centimeter and t is in seconds. Alright, so now let's determine the frequency. So we want to find what is the frequency. So from here we know that omega is equal to 40 pi. Therefore, since omega is equal to 2 pi f, so frequency is equal to omega over 2 pi, where omega is 40 pi over 2 pi, then the frequency is equal to 20 Hertz. Okay. Okay, second, we want to find what is the wavelength. Okay, so when we want to find the wavelength, lambda, remember that k is equal to 2 pi over lambda. Okay, so this is for k. Okay, look at to the equation. Okay, so k is equal to 0.5 pi per meter. Then we can find lambda. So lambda is equal to 2 pi over k and 2 pi over 0.5 pi. Okay, so 2 divide 0.5. So it's equal to 4 centimeter or 0.04 meter. Okay, and number 3, the speed of the progressive wave. So it's v is equal to f lambda. Alright, so we can straightly substitute the value where the frequency is 20 Hertz and lambda is 0.04 meter. Alright, therefore, V is equal to 0.8 meter per second. Okay. The last one, the distance between two successive nodes. Okay, we want to find the distance. Okay, remember that lambda is equal to 0.04 meter. Means that one wavelength. Okay, so here is 0.04. Okay, 0.04 meter. So the distance between two successive nodes, okay, is here to here, nodes to nodes. Okay, so it's half wavelength. Okay, therefore lambda over 2, it's equal to 0.04 over 2. So it's equal to, okay, 0.02. Okay, we can write as the distance between two successive nodes equal to lambda over 2, and it's equal to 0.02 meter. Okay, so here is node and this is node. Okay, so let's say this is a graph y against x. Alright, so question 9b. Okay, question 9b, we have a firecracker explodes high in the air. The sound spreads out uniformly in all directions. The intensity of the sound is given, where I is equal to 3.0 times 10 power of negative 6 watt per meter squared. Okay, so at a distance of 90 meter from the explosion. Okay, so I put it as I1. So when the distance R1 is equal to 90 meter, means that the person will hear the intensity of the sound is 3.0 exponent negative 6 watt per meter squared. Determine the sound intensity at distance 60 meter from the source. Okay, so we want to find what is the intensity if R2 is equal to 60 meter. Okay, okay, so let's write the equation of the intensity first, where I is equal to power of the source over 4 pi r squared. So this is the equation. Okay, so from here we can find first what is the power of the source. Okay, so we can calculate what is P. From the first information, when I1 here and R, so from the first information we have I1 and R1, so we can find what is P, where P is equal to I1 times 4 pi R1 squared, where I1 is 3.0 exponent negative 6 and 4 pi R1 is 90 squared. Okay, so the power is equal to 0.305 watt. So this is the power of the source. So since we want to find what is the intensity when the distance from the source is 60 meter, so kita start dengan bunyi yang sama daripada firecracker yang sama. So means that the power is constant. It's from the same firecracker. So now we want to find I2. Therefore, I2 is equal to P over 4 pi R2 squared. So the power is 0.305 over 4 pi and R is 60 squared. Okay, so I2 is equal to 6.74 exponent negative 6 watt per meter squared. Okay, so this is the answer. Okay, so let's move to question number 10. Okay, question 10, we have a steel wire and the length of the wire is 6 meter. Okay, and the cross-sectional area A is equal to 0.02 centimeter squared, and make sure you change to meter squared. Okay, remember 1 meter is equal to 100 centimeter, but as we have squared here, so we need to square the 100 below. Okay, so it's equal to, so this one we can cancel, and the area is equal to 2 times 10 power of negative 6 meter squared. Okay, And given that the wire will extend 3 millimeter when we have a mass of 10 kg attached to its end. Okay, so let's say this is the wire and we attach the mass where the mass is 10 kg. So there is an extension, okay, ataupun elongation. E is equal to 3 millimeter. So now we want to calculate what is the tensile stress. Okay, so the tensile stress is equal to F over A. Okay, so when we put a mass of 10 kg, okay, so when we attach mass of 10 kg to the wire, means that the force here is the weight of the mass. Okay, means that this is the wire, then we put a force here downward, which is the weight of the mass. Therefore, we can calculate here the tensile stress is equal to mg over A. So, mass is 10 kg, 9.81, and the area is 2 times exponent negative 6. Okay, and the answer is equal to 4.91 times 10 power of 7 Newton per meter. Okay, make sure your area in meter. Okay, so next we want to calculate what is the tensile stress. Okay, next we want to calculate what is the tensile strain. Okay, where the tensile strain is equal to E over L0. L0 is the initial length of the wire. Okay, so I want to highlight the equation. Okay, so elongation is given as 3 times 10 power of negative 2 and the initial length of the wire is 6 meter. Okay, therefore, the tensile strain is equal to 5 times 10 power of negative 4. So, no unit. Okay, tak ada unit because elongation the unit is meter, length is the unit is meter, so cancel the unit. So, for the tensile strain, the answer without any unit. Alright. Okay. So, let's proceed to question number 11. Okay, questions 11. We have a metal rod A of length 50 cm is heated from 0 degrees Celsius to 80 degrees Celsius. Means that we have a rod where the initial length of rod A is equal to 50 centimeter and the temperature is T initial is 0 degrees Celsius while T final is equal to 80 degrees Celsius. Okay, so we have another metal rod B of the same length heated through the same range of temperature. So means that this is constant. Okay, so we have another length which is B, where B also equal to 50 centimeter. Okay, and given that for rod A, it expands by 0.5 centimeter. Okay, means that the delta L is equal to 0.5 centimeter. While for wire B, the delta LB is equal to 0.02 centimeter. So this is delta LA. Okay. So now we want to calculate what is the coefficient of linear expansion for metal A and B. Okay, so now we have two different types of metal rod. Okay, so it depends on its coefficient of linear expansion alpha. Okay, if you can compare the delta L of A is bigger than the delta L of B. Means that for metal A, it expands faster compared to the metal B. Okay, so let's write the equation for the linear expansion. So we have delta LA is equal to alpha A L naught A delta T. Okay, so now we want to find what is alpha A. Okay, so this is our objective. Okay, so rearrange this equation. We have alpha A is equal to delta LA over L naught A delta T. Okay, so now we have all the values. we can substitute delta LA is 0.5 times 10 power of negative 2 meter over L naught A is 50 centimeter, convert to meter, it's 0.5 meter, and delta T final minus T initial. Okay, so here delta T is equal to T final minus T initial, and it's 80 degrees Celsius. Okay, so we can substitute here. So delta T is 80. Okay, therefore alpha A is equal to 1.25 times 10 power of negative 4 degrees per Celsius. Okay, so this is for A. Okay, while for B, we can do the same thing. So now delta LB is equal to alpha B L naught B delta T. So we want to find alpha B now. Okay, so alpha B is equal to delta LB, which is 0.02 times 10 power of negative 2 meter over L naught B is 0.5. Okay, or 50 times 10 power of negative 2 meter, and delta T is the same as metal A. Okay, and alpha B is equal to 5 times 10 power of negative 6 degrees Celsius. Okay, so look at here, when we compare the coefficient of linear expansion for metal A and metal B, what we can say that if the coefficient of linear expansion is bigger, means that the object or the metal rod will expand faster. Okay, when we compare delta LA and LB, we can say that alpha A is bigger than alpha B. Alpha A is bigger than alpha B. Therefore, the expansion of A must be faster compared to the expansion of B. Okay, sebab tu delta A dia lagi besar daripada delta P. Okay, so let's move to question number 12. Okay, question number 12. So we have a 15-liter tank is filled with compressed oxygen at pressure 60 atm and the temperature is 30 degrees Celsius. Sorry. Okay, so now kita keluarkan semua maklumat. So we have the volume is 15 liter. Okay, and it's equal to 15 times 10 power of negative 3 meter cube. Okay, and the pressure is in atm unit. Okay, so you can change the unit into Pascal. So it's equal to 60 times 1.013 times 10 power of 5 Pascal. Okay, and the temperature is equal to 30 degrees Celsius, and it's equal to 30 plus 273.15. Okay, so it's will equal to 303.15 Kelvin. Okay, so now we want to find, so given that the molecular mass, okay, so given that the molar mass is equal to 32 gram per mole, and it's also equal to 0.032 kg per mole. Okay, so now we want to calculate the mass of the compressed oxygen. Alright, so so what equation that we can use? We have the molar mass. Okay, so if we use this equation, mass over molar mass, okay, we need to find first what is the number of mole, N. Okay, so we want to find what is the mass here, M. We do have the molar mass, but we need to find this one, okay, N. Okay, where PV is equal to nRT. Why I use this equation? Because I have P, I have V, and I have T, the temperature. Therefore, I can find N is equal to PV over RT. Okay, so now it's equal to, so P is equal to 60 times 1.013 exponent 5, and the volume is 15 times 10 power of negative 3. Alright, over R is the constant 8.31 and the temperature is 303.15 Kelvin. So from here we have our N is equal to 36.19 moles. Okay, so now we can find the mass of compressed oxygen. So it's equal to M is equal to Nm. Okay, so I will highlight the equation. Okay, so it's equal to 36.19 and the molar mass. So it's equal to 36.19 and the molar mass must be in kg, so 0.032. Okay, therefore M is equal to 1.16 kg. Okay, so B, we want to find what is the RMS speed of oxygen molecules, or VRMS. Okay, so in order to find VRMS, I'm going to use this equation. Since we have the temperature and the molar mass, I can straightly use 3RT over M. Okay, so 8.31 and the temperature is 303.15 over the molar mass in kg, 0.032. Therefore, VRMS is equal to 485.98 meter per second. Alright, and the last one we want to find the density of the oxygen. Okay, so density we can use equation. So since we have the mass of the oxygen from previous question, we can straightly use density is equal to M over V. Okay, where density, the mass from the previous questions, 1.16 kg over the volume is given, right? So 15 times 10 power of -3. So density is 77.20 kg per meter cube. Okay, ataupun tak nak guna formula yang ini pun boleh. Okay, you can use another equation, you can try. So as we have the pressure, okay, in this situation we have all the values like pressure, so we can find the density from VRMS equation, where equation VRMS is equal to VRMS square root 3P, where P is the pressure over the density. So you can find the density here. Okay, so you will get the same answer, which is 77.2 kg per meter cube. Okay, so you can try this equation. Mana-mana pun boleh. Okay, so finish question number 12. Okay, for the last question, question number 13 from last chapter. Okay, so we have a monoatomic ideal gas is changed from state A to state E and then to state D. So let's highlight. So we have from A to E and E to D. So you can see here from A to E. Okay, so this process is isobaric process since the process is at constant pressure. Okay, so we can write that from A to E, it's isobaric. Okay, constant pressure. So from E to D, so while E to D, this is isothermal process because E to D is on the same temperature. Okay, line 2, the dotted line showing that the line for the temperature. So E and D are on the same line, so means that the process is isothermal process. Okay, so it's constant temperature. Okay, so the question asks us to find the total work done of the gas for the path A to E and to D. So we want to find what is the work done from A to E. What is the work done from A to E and also work done from E to D. Okay, let's start. So as we know, from A to E is the isobaric process. Therefore, we can find work done from A to E. Okay, I write AE. So it's equal to P delta V. Okay, so before we start the calculation, look at here. The unit for the pressure is ATM unit. So make sure you change to the Pascal unit. So we have 2.5 ATM. So it should be 2.5 times 1.013 times 10 power of 5. And V final minus V initial. So look at the arrow. The arrow is in this direction. Means that here is V final and here is V initial. So it should be 4 times 10 power of negative 3. Okay. The unit is in liter. Make sure you change to meter cube. Okay. Kena darabkan dengan 10 power of negative 3. Okay. So minus 2 times 10 power of negative 3. Okay. So you're going to get 506.5 joule for the work done from A to E. Okay. And how about for the isothermal process, we have, saya guna warna lain lah. Okay. So here we have work done from E to D. So it's isothermal process and we can write as nRT ln V final over V initial. Okay. So we want to substitute the temperature here, but we don't have the value of the temperature. Kita boleh cari. Okay. Sama ada kita nak cari ataupun kita tukar this equation nRT. Since PV is equal to nRT, we can substitute here as PV ln VF over VI. Okay. So when we substitute the value, we know that the pressure, okay. Pressure ni mesti sinilah. Kat mana dia mula tadi? Kat E kan? So the pressure should be 2.5 times 1.013. Okay, change to Pascal unit. And the volume, okay, at the starting point. So must be initial volume and initial pressure. So 4 times 10 power of negative 3 ln. So V final is 8 and V initial is, kita balik. Betul. Okay. So 4. Alright. Okay, V final over V initial. Okay, so finally, we have WED is equal to 702.16 joule. Okay, therefore, the total work done from A to E and to D is equal to 506.5 plus 702.16. And the final answer is 1208.66 joule. Okay. Alright. So yang ni, kalau you tak nak cari, kalau you tak nak guna yang ini, PV equal to nRT, you can find the temperature first. Macam mana kita nak cari the temperature? Okay. So look at here. You can find the temperature, okay, at point E by using PV is equal to nRT. P ada, V ada, N ada, R ada. Then you can find what is T. Okay? Awak boleh cuba. See you in the next session. Don't forget to like, share and subscribe channel Madam Fika Fiki. Jumpa lagi. Assalamualaikum dan selamat sejahtera.